Chapter 18 is working with radicals. Let's start off with the first problem, taking the square root of 6, and we want to square it. Remember what squaring means. Squaring means to repeat. So I'm going to take the square root of 6 and multiply it by itself. That gives me the square root of 36 by the law of radicals that says the square root of a times the square root of b is the square root of ab. But square root says find me an answer when multiplied by itself gives me the radicand of 36. And that answer was 6. So an observation, if you take any radical when multiplied by itself, you get the radicand, which is the 6 on the inside. So any radical times itself is always the radicand. You don't have to go through this lengthy procedure. We need to pick up some rules or laws of radicals. So for the next problem, we're going to have 8 radical 192. One of the first laws of radicals is to leave no perfect square in the radicand. In other words, if there is a square inside the radical, extract it. Well, let's see if we can write 192 as a product of values, one of which is a square. 8 parentheses. Let's see, 2 does go into this. 2 times what? 2 into 19, 2 nines are 18, and 1 over 2 into 12 is 6. But I see that factors again. How about 8 times 2? Pull out another 2. So 2 into 9 is 4. 2 into 16 is 8. But I can see that factors further. So I'm going to write this 2 times 2 is 4. But 48 is 4 12s. And I believe that 16 by 12, and I'm just going to double check it, is 192. But just make sure. 16 times 12 is 192. So we have factored 192 completely. Well, not completely. We need to, I'm seeing something else. I'm going to write this again as 8 radical 4 times 4 times 4 times 3. Each of these 4s are squares. Each of those 4s are squares, and we can actually write this 4 times 4 is 16 times 4 is 64. So yes, 64 is a square. And according to the rule above, I can write this problem as 8 radical 64 radical 3. That I can extract the square root of 64 from here, but I got to remember that what's outside is a multiplication symbol. I'm multiplying the 8 that's on the outside by the square root of 64, which happens to be 8. So it's 8 times 8, left with radical 3. Final answer is 64 radical 3. This is the radical simplified by the rule, no perfect squares left inside the radicand. I did it out tediously, but you can see the idea. This problem, we're going to do the same thing, simplify the radical. So we have minus the radical 48x to the 5th y all over 49. I'm going to split the radical into 2 radicals so that one of them is all perfect squares and the other is the leftovers. So I have minus square root times the square root 48. Try to extract the largest perfect square from 48. 16 and 3. 16 and put a 3 over here. X to the 5th. When you have exponents, an even powered exponent is a square. So I'm going to write x to the 4th and an x over here. 49 we know is a square. And all that's left here is y. So I've extracted under one radical all the squares, 16x to the fourth over 49, and the remaining part is 3xy. Taking the square root of this, we're going to have minus 4x squared. If we're taking the square root of an exponential, the root 2 dividing into 4 gives me the power 2. Square root of 49 is 7, and we're left with the radical 3xy. Next problem, we have 9 square root of 14x cubed y to the 6th. Again, separate the radical into two radicals. One radical contains all the squares, the other radical contains the remainders. 14 is not a square, so I'm going to put it over here. X cubed has an odd power. Drop the power down to an even power, and then the remaining power is there. Y to the 6th is an even power, so I'm going to leave it there. Notice there's a times symbol between the 9 and the radical, so we have 9. The square root of x squared is x. The square root of y to the 6 is y cubed, and I'm left with the radical 14x. So there's the radical in standard simplified form.